All right, guys, welcome back. So today we're going to learn about net absolute value integrals. So one of the things that was on the warm-up that we didn't have today was the idea of a net change in position. And the idea you found was a net change in position is just kind of what is your final position minus your initial position. And thinking about the fundamental theorem, you just integrate the derivative position, so you just integrate the velocity. Okay, so that gives you a net change in position. But let's say I drive to work one day. So my car starts the day in my garage, and I drive to work, and then I go back to work, and at the end of the day, my car is back at the same spot. So my net change in position is 0. But how far did I actually drive? Right? My net change in position was 0, but how many miles overall did I drive? And that's what we're going to try and answer today with something called the total distance traveled. Okay. And when you see this phrase total distance traveled with those particular words, what that means, or just distance traveled, what that means is it is the integral from A to B, not just the velocity, but the absolute value of the velocity. So basically what you're trying to do is you're trying to count forwards and backwards velocity. So if I traveled 3 miles to school and then 3 miles back home, my net change in position is 0, but my total distance traveled is 6 miles because I went 3 there and then 3 back. So I count the forwards and the backwards velocity. So this is, of course, always going to give me some number that's greater than or equal to 0. So anyway, so that was a little bit of a distraction because now, maybe not distraction, but an intro, because now the big question is, okay, how do I integrate an absolute value? How do I integrate an absolute value of some function like that? Okay, and we're going to show some examples in a minute, but first off, let me just talk about like the general setup. We're going to split it into parts. We're going to split it into parts when the inside equals 0. So when that f of t or f of x or whatever equals 0. And then once I've split it into part, then I do the absolute value. Let's not put 0. I do the absolute value of the function on that interval. And then what I'm going to do is I'm going to take the absolute value of each section and add those together. Okay, so I'm going to basically break the integral into different parts. So instead of a to b just doing one integral, I break it into a couple different parts, do those integrals separately, and then add them together. So let's go ahead and look at an example. Suppose I ask you to integrate -2 to 2 of absolute value of x dx. So your first thing should be is I'm going to split this up when the inside equals 0. And I mean the inside of the absolute value. So when that x equals 0. So what I'm going to do is I'm going to say, all right, I'm going to go integral -2 to 0, and now I'm just integrating without the absolute value. And then I'm going to go integral 0 to 2, and I'm going to integrate without the absolute value. And then once I've split it up, now I do both integrals, and then I'll take the absolute value of my answer, and then add those together. So I'm going to do the integral from -2 to 0, take the absolute value of that, do the integral 0 to 2, take the absolute value of that, and then sum those together. Okay, now these integrals, of course, you already know how to do. This is just x squared over 2 going from -2 to 0, and that's just going to be 0 minus -2 squared minus 2, so that's -2. When I do this integral, of course, I have x squared over 2 going from 0 to 2, so I have 2 minus 0, which is 2. Now, my last step again, I need to take the absolute value of each part. So those are my two answers. So now when I add them together, which I almost spelled correctly, I do absolute value -2 plus absolute value 2, and that gives me 4, right? 2 plus 2 is 4. Okay, so that's how you find that area. Now, you might also notice, of course, that you could have found this like graphically by drawing a picture, right? If you draw a picture, this is -2 and that's 2. The triangles on both sides have an area of 2, so it sums up to be 4. That you get the same answer. Anyway, so that's how you can do it without looking at a graph. Let's look at another example. Suppose I ask you for the integral 0 to 3 of absolute value x squared minus 4 dx. All right, so we're going to split this up, and that should be your first step. We're going to split this up when the inside equals 0. So that happens when x squared equals 4, so we're going to split it at 2 and -2. Now, negative 2 is not between 0 and 3, so that doesn't really help us too much. But we will split it up at 2. So let's go integral 0 to 2 of x squared minus 4. And let's go 2 to 3 of x squared minus 4. Okay, now this should be, again, pretty straightforward, right? You can do these integrals. This is x cubed over 3 minus 4x going from 0 to 2. So now I plug in 2, I have 8 thirds minus 8, all right? So that's negative 16 over 3, because 8 is 24 thirds. So this is x cubed over 3 minus 4x, going from 2 to 3. When I plug in the 3, I get 27 over 3 is 9 minus 12, and then minus, actually the same 2, right? You use the same point of both. So minus 8 thirds minus 8. All right, so we got negative 3 plus 8 minus 8 thirds. Oh, geez. So that's 5 is 15 thirds. I got 7 thirds. So those are my two answers. Don't worry too much about fractions. Now I just take the absolute value of each one, kind of make them both positive there. So 16 thirds and 7 thirds is 23 thirds. Okay, so that's how you do it. We split it into a couple different parts, and then I take those two integrals for each of the separate parts, and then just take the absolute value of each answer, and then add those together. Each and then add. Now, I did not do this, but if I had given you, for example, like, let's say on this one, I asked for the integral negative 10 to 10 of x squared minus 4, then in that case, because there were two cases split it up, I go like negative 10 to 2, I go negative 2 to 2, and then I go 2 to 10, and I would have to add all three of those parts together in that case. Okay, let's look at a seemingly unrelated problem. So let's suppose now, mud brown, let's suppose someone asks you to do the integral 4 to 7 of square root x squared minus 10x plus 25. Okay, now, gosh, you might think at first, like, well, this looks kind of like a u-sub to me. And that would be my first inclination as well. But when you try a u-sub, you're going to see you run into problems right away, right? Because your derivative is 2x minus 10. I don't have anything like that at all. That doesn't work. Jeez. So I wonder if there's a way that I could rewrite this. And in fact, there is. So let's see. I could factor that out. And when I factor that out, that turns out to be integral 4 to 7 of square root. Okay, so that's x minus 5 squared. Ooh, that looks like something I can cancel. So let's do a little non sequitur. This is the time in the class when I would ask, what is the absolute value, or it's not that, geez, not an integral. What is the square root of x squared? And you would say it's x, and I would tell you you're wrong. It's actually the absolute value of x. Because think about it. If your function is the square root of x squared, like, yeah, if you take the square root of 2 squared, it's just square root of 4, which is 2. But if you take the square root of, say, negative 3, like a negative number, it's the square root of negative 3 squared, which is square root of 9, which is actually positive 3. It's always going to give you an absolute value. So if you have, like, the square root of f of x squared, like, that's just going to turn into absolute f of x. So in this integral, you're just doing the integral 4 to 7 of absolute x minus 5. Okay. And I'm not going to finish the problem, but you're going to split this when the x minus 5 is 0, so you're going to split it at 5. So you say, okay, what's going on from 4 to 5? And then what's going on from 5 to 7? And then you'll just kind of be off to the races on those problems. Okay, so that's the basics, and I'll be back with part 2 in just a minute. Thanks for watching, and then bring me some questions in class on these absolute value integrals.